Well, the UPS man came, delivered a package, and it wasn't what I expected. Actually, I know what's inside. I didn't expect the packaging. I guess in hard times, you use whatever box you have at hand. So this came from the Midwest somewhere, and it's from eBay. And it's something I've wanted for a long time. I always thought they were cool. I never really needed one. I still don't. I mean, obviously, I don't need one, but I've always wanted one. I always thought they were a nice design. And oh, we got a lot of peanuts, so that's a good thing. Although the peanuts are going to get everywhere, so I'm going to extract it out of the box and leave the peanuts behind. It's packed pretty well. Okay. All right. Definitely looks like something from Hewlett-Packard's old days. Nice case. That gray color. The handle sort of still works. It's got the old style power cord. Those aren't always that easy to find, but I have some. This one has option 1. Option 1 is, I don't know. It says 115 to 230 volts, 50 to 400 cycles. Anyway, here's the big reveal. It is a multimeter. It's really cool. Let me lower the camera down. All right, so we have an off position, a battery position. So this thing has the ability to be battery powered. I'm sure the batteries are dead. DC volts plus and minus, so it didn't have auto reversing back in the day. So you put it in, if it looked like it's backwards, you just flip the little dial here instead of changing your leads. Ohms, which is a separate terminal. So this is for voltage, this is for ohms. AC volts. So DC volts, AC volts, ohms, no current. And then a range switch. And a DC offset potentiometer at the bottom. So, pretty cool. Let's see, what does the meter say? dBm, 600 ohms, 0 dBm equals 0.775 volts, average responding RMS volts. So it does RMS, AC RMS volts. So very cool. And as Dave says, don't turn it on, tear it apart. I think. I'm not sure if I need to take that one out. I certainly need to take this one out. I may need to take these out. Yep. All right. Let's see. And inside is battery. Replace battery with Everready or RCA, or maybe Everready was RCA. 763. So, very strange battery. I'll have to take that out. But super clean. Nobody's been inside this thing. Don't know what years these were made. There's some stamps on the circuit board here. Get out a flashlight. Test 993. I don't think this was made in 93. That's earlier than that. Well, maybe 1993. That just sounds too late. Let's see, here's a transistor, a 2N 3709, 3703. Let's see here. There's a date code on the transistor. 1980? Maybe? That sounds about right. Oh, let's see here. QA inspector, 935. Now, it's certainly not 1935. So 935. So I don't know what those dates are. Very strange. Let me move the camera up so you can get a better view. Right. Here is our battery. It's 22.5 volts. Make sure you get that half a volt in there. 22.5. Little plastic doohickeys. And the battery comes off. Plus is red. Remember that. Looks like there's a little latch down there. That one came out. There we go. So, how many, raise their hands, how many people have seen one of these batteries? An Everready Nita 710, number 763, 22.5 volts. It's a paper outside. I'm not sure how many cells are inside, how it was constructed. Date sold, there's no date on it, darn it. I don't know if you can buy these anymore. That'll be interesting. I'll see if we can't buy one of these. That'd be cool. So, very clean inside. It's not easy to get to one of these. It's not easy to get to one of these PC boards. Oh, yes, it is. Yes, it is. Thanks to HP engineering, the sides come off. All right. I'll leave my screws. There we go. Always see the potentiometers. There's no date codes on this side. It's beautiful, huh? All gold. Push-on connectors over to this big main switch here. Yeah, let's see, off adjust, offset adjust, 1 volt range, 0.3 volt range, and the 0.1 volt range, so for calibration. And there's something over here which is 1 megacycle. So oscillator over there that you adjust. Yeah. What the hell? What the heck? Sorry. Let's open up the other side. It's very hot in the garage today. It's like 100 degrees outside, and I turned the air conditioner off because it's very noisy. More potentiometers. This thing is just nothing but potentiometers. I guess that's all you really need. So 1K adjustment times 10, amplifier balance, regulator adjust, 6.7 volts. Nice switch down here with all of the range stuff on it. Oh, that's interesting. 3 volt, 100 kilocycle adjust. So there must be an oscillator inside there. So tweak that there, I guess. All right, so here is a TI transistor, and I bet you it has a date code on it. So 1984. That sounds right. That would have been at the probably at the tail end of this thing being built. I joined Hewlett-Packard in 1980, I believe. Give you a better shot of the front here. And a mirrored scale to get rid of the parallax error. Looks like the meter needs to be zeroed a little bit. That's this adjustment here. Looks very nice. The model number. So it is a 427A. Now there was a whole bunch of 400 series in this particular box. And some were very famous. There was a bunch of 400 A, B, C, D, blah, 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 a whole bunch of them. And they were high frequency AC voltmeters that had a remote probe with probably a germanium diode in it or something like that. But they were very, very accurate. A lot of ham radio people covet those things. I don't really have any use for those. I just thought this one was super cool. It was one of the few multimeters. You got an AC voltmeter or DC voltmeter. I believe there was one of these that was an FET version that was later that had a much higher input. I don't think this one's FET. I'll have to look around. There's some strange looking transistors here. These are really old school packaging. But yeah, I'll have to find a data sheet for this and take a look at it. So I just typed in the battery number into Amazon, and $50. Oh, that's absolutely ridiculous. 22.5 volt alkaline battery for $49. I guess they don't sell many of these. Let's see, 2100 milliamp hours, chemistry alkaline. Color multi, unisex. It ranks 1,196,107 in sports and outdoors. In swimming, it's number 6,781 in swimming equipment. Interesting. Oh well. I'm sure there's a way to rebuild this back with something different. I'll have to figure out, see, 9 volts, see, 9 into 22, 1, 2, 3, 4, no, 3, yeah. Anyway, interesting. Here's our ever-ready battery, the 9 Lives radio battery with the cat. I went ahead and kind of surgically opened up the bottom of it. It doesn't look anything worse for wear from the top, but I did open it from the bottom so we can see what's inside, and there's lots of goodies inside. And I think I can slide it up. Let's see here, push on these. These terminals stick out, they're threaded terminals. I can push on those and slide it out. There it goes. There we go. Oh, there's a little spacer block in here. A little piece of press board. And, oh, a couple of spacers. A spacer for the side made out of cardboard, and a spacer for the top made out of double ply cardboard. A little bit of battery goo on that. But look at this thing. Wow. I zoomed in all the way? Almost. Yeah. All of these cool cells in here. I have no idea how this is constructed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if they're 1.5 volts, 15 plus 2.5, that's not right. So it's 22. Oh, I can't do math in my head anymore. You know, I have a degree in mathematics, but I can't do algebra. 22.5. How many did I say there was? 15 of them? 1.5 volts. Oh, duh. I just can't, like I said, I just can't do math in my head. So, yeah, so 15 cells. So I downloaded the electrical service manual for this thing and looked to see where the battery is used. The way that it's used in the circuit is that there's AC coming in, goes through the transformer. The transformer gets rectified. It gets rectified with 1 diode and 1 capacitor. And that's how it gets rectified into, guess, 22 volts. So the switch in the back, here, you flip it up, it says battery. Flip it down, it says line. All that does is either connects the battery at that point or the rectified voltage at that point. So that's how it does its battery thing. And then it generates plus and minus 6.7 volts. Kind of a weird number, but plus and minus 6.7 volts. I've seen 6.7 volts in other HP equipment, so it must have been a favorite voltage of theirs. If it is 6.7 volts, and there is some circuitry to regulate those voltages and stuff. I don't know how large the dropout voltage is on those regulators, but it may be that 2 9-volt batteries would work just fine in this thing. So they're not going to have the amp hours of this thing. This thing has like 2 amp hours. I don't remember how much 9-volt batteries have in them. I don't remember offhand, but they're like AAA cells. They're like really tiny. But I can imagine 4 9-volt batteries, 2 on one side and 2 on the other side for extra current, and that probably would power this thing up for some time. So I think that's pretty cool. The other thing I found out when I was looking at the schematic for this thing is it is a FET input device, and it guarantees input impedance of 10 megohms across all range settings. 10 megohms on the AC and 10 megohms on the DC. So that's quite good. So I think the next thing to do is to put this thing back together and try it out. It has a little bail here on the bottom, so it can flip up, so thanks for your viewing better. Let's see here. Let's turn it on. Battery, Wow, is there actually juice on that battery? 1.5 minimum. And it went this way. Looks like 1.35. Maybe that battery's okay. I don't know. Let's see. Plus and minus. There's an offset, so we'll have to adjust that. There's an offset. I remember seeing an offset in there. So when you flip between plus and minus, you're getting a slight deviation in the reading here, but that's an adjustment inside. There's an ohms, and there's an AC volts. So let's do DC volts plus. Let's see. We have common and volts. So I hope they're the right. Yeah, they're the right. Spacing, 3/4 of an inch, I think that is. And let's, I guess this is my volt. I have to reach across here, but this voltmeter will be okay. Let's hook it up. And we're pegging. There we go. So it pegs on the 10, and on the 30, we're getting 12.6. Ooh, and we're 12.6 or 10, yeah, 12.6, and we're measuring 11.5. So it isn't quite right. Let's move down to 10 volts. I have it at 10.064, and we're measuring at 11. So definitely need some adjustment, but I think that's going to be very easy in this thing. DC 0. DC 0. Maybe I can do that. Let's see. DC 0. It is DC 0. Oh, I should have done that. So DC 0, there we go. And now when I put 10 volts in, there we go. It's measuring 10.3. And it's 10.06. Let me squeeze that down just a little bit. I can make it accurate. Yikes. There we go. Oops, I went too far. 10.008. And we're measuring at about 10.25, something like that. So I'm sure it needs calibration, but it works. That's very cool. It works. And so let me do the minus. I'm going to go to minus. Oh, and we get to do this DC 0 thing. So that's good. And then we'll do minus. So we'll go this way. Yep, same voltage, same exact reading. So very nice. So well, it's nice to have an analog meter for some things. For like audio work, watching it flip around, it's much better than having a digital meter. So I think this will come in handy for the audio work that I'm doing. Let's see if it knows how to measure resistors. That's pretty cool. Let's see here. Let's find a resistor laying around. It's got to be one laying on my bench here. Here's one. Looks like a 3. It's orange, red. So I think that's 3.3K. So let's go to ohms. And we'll do the ohms 0. Okay, there's ohms 0. And we'll put this on. And then ohms is, oh, I have to go to the blue connector. There we go. So we're at 1K ohms, and we're measuring 2.4 K ohms. 2.4 K ohms. Okay, so let's get out a calibrated DVM and see what this says. This says, need 6 hands to hold everything so it doesn't fly around. Why is this? There we go. 3.25K. So this thing's way out of calibration for ohms. There may be some dried up electrolytics in here, so I'll have to take a look at that too. But I think it's a pretty simple circuit. I don't think there's a lot of fancy stuff in there. So I like it. I'm really curious about this battery. Since the battery has juice in it. Oh, well, let's try it out. Let's see here. Let's see. We're measuring about 2.5K, 2.5K. All right, so let's turn it off. And I'll flip the switch on the back for battery mode. And we'll flick it to ohms. And yeah, that battery's dead. That battery is dead. There may be, oh yeah, now we're not measuring anything at all. Let's go back to, yeah, that might just be some weird part of the circuit. If the battery is completely dead, maybe that's what it measures. I didn't think that battery was any good. Anyway, I think I'm going to enjoy this thing. Next step is let's pull the sides off again, and I'll get the manual out, and we'll see if we can't calibrate this thing.